We're going to continue our discussion. We're going to continue our discussion of methods of integration. The method that I'm going to describe today handles a whole class of functions of the following form. You take p of x divided by q of x, and this is known as a rational function. And all that means is that it's a ratio of two polynomials, which are these functions p of x and q of x. We'll handle all such functions by a method which is known as partial fractions. And what this does is it splits p over q into what you could call easier pieces. All right, so that's going to be some kind of algebra, and that's what we're going to spend most of our time doing today. I'll start with an example, and all of my examples will be illustrating more general methods. The example is to integrate the function 1 over x minus 1 plus, say, 3 over x plus 2 dx. Now that's easy to do. It's just, we already know the answer. It's natural log of x minus 1 plus 3 times natural log of x plus 3 plus a constant. So that's done. Okay? So now here's the difficulty that is going to arise. The difficulty is that I can start with this function, which is perfectly manageable, and then I can add these two functions together the way I add fractions. So that's getting a common denominator. And so that gives me x plus 2 here plus 3 times x minus 1. And now if I combine together all of these terms, then altogether I have 4x plus 2 minus 3, that's, I guess, minus 1. And then if I multiply out the denominator, that's x squared plus, oh, that 2 turned into a 3. That's interesting. I hope there aren't too many more of those transformations. Is there another one here? Oh, it happened earlier on. Wow, that's an interesting vibration there. Okay. Thank you. All right. So I guess, yeah, my 3s were speaking to my 2s. Somewhere in my past, huh? Okay. All right. Anyway, I think this is now correct. Here. Okay. So the problem is the following. This is the problem with this. This integral was easy, right? I'm calling it easy. We already know how to do it over here. But now, over here, it's disguised. It's the same function, but it's no longer clear how to integrate it. If you're faced with this one, you say, what am I supposed to do?